have spent a mathematics lifetime learning about functions. And then today we're going to flip it literally, and we're going to call inverse functions. And let's talk a little bit about notation real quick. You're used to f of x. F of x is a function, and this would be its inverse, f negative 1 of x. So whenever you see that raised to the power of a negative 1, that means inverse. So get comfortable with that, because now that you know it, you'll see it forever and from now on. Inverse function. Now, I think the first thing I want you to do is take a second, and I want you to plot these points. Now, those are a list of points, and normally I would never tell you to connect them, because there's nothing that says to connect them. But just for the sake of being able to see this better visually, I would like you guys to make the triangle. Looks like everybody's feeling pretty good about that. Okay, if I have a point that is x and y, guess what the inverse point is? Trade in places. That's all we're going to do. So the inverse function then would be trade the x and y places. Once you have those inverse points written down, I'd like you to graph those points. And then do the same thing, make the triangle. I think our Veterans Day video kind of sombered you guys up. Did me. What do you notice about the function and its inverse? Anything special? There's not a wrong answer. Tell your neighbor something that you notice if you don't want to tell me, but I should hear talking when you're telling your neighbor. Can you now tell me what your neighbor said?
It's different.
It's different. Okay, it is different. But is it also the same? That's what I heard you guys say. I heard different. I heard same. It's for sure same, but it's been transformed somehow, hasn't it? It's been rotated and flipped. What has it been flipped across? This is actually a big deal today. Anybody have any idea?
Depends on which y equals x.
The y equals x axis. So this is y equals x. So if I was to graph that, the y-intercept would be 0, and my slope would be up 1 over 1, right? That's what the y equals x axis is. And I'm just going to graph that with a dotted line there. So it is reflected, right, across that y equals x axis. That's what happens when we have an inverse function. Let's graph this line down here. Do me a favor, graph the line. It says graph f of x and its inverse. You can graph f of x. I could if I could see better. Some of you are finishing up, so I'll give you the second longer. Now to find an inverse point, I told you it was pretty easy. All we had to do was trade the x and y places, right? To find the inverse of a function, it's just a little bit hard to, it's not as easy as flipping. So what I'm going to do is probably move this down there so I have some workspace. I'm going to change that f of x to a y. You guys know it's a fancy y. You're used to that. And then I'm going to trade the x and y places here. So x equals 2y minus 1. All right, so let's see what I do. Replace f of x with y, and then I trade x and y. And now I want you to solve for y. All right, so I would add 1, and then I would divide by 2. Because we're going to graph this, I'm going to choose to say 1/2 x plus 1/2 equals y. Questions with what I did? Okay. But I want to remind myself that this was the inverse. Run out of room here. So this was the inverse of f. I got 1/2 x plus 1/2. Now I'd like you to graph that line, please. That was impressive.
That's her sneeze.
Impressive.
It's not.
It's obnoxious, is that what you're
A
saying?
little bit.
All right. Does this look like it's been reflected across the y equals x axis? What do you think? Here, I'm going to put it in there for good measure. All right, based on our site, does that look like it's been reflected across the y equals x axis so we can verify we did it right?
Yeah.
Okay. Why do you think there are butterflies on this page? Yeah, I kind of call this the butterfly effect, but something else in some movie somewhere. But I know I've done it right if I get, kind of those butterfly wings. I've got it balanced on that y equals x axis. So how you feeling about the lesson so far? So far. How do I find the inverse? What do I do? Flip what? X and y. And if it's an equation, I flip x and y, and then I have to solve. Which you guys know how to do that. That's no big deal. And you're not going to mind this so much because we've just spent 2 days on it. Do you think it's always convenient to graph 2 functions to verify if they are inverses or not?
No.
No. So we would like to be able to verify that 2 functions are inverses algebraically. I don't want to have to rely on my vision test here every time to see if I come up with beautiful butterflies. So this is a huge page. It probably could have been combined with the other ones, but it wasn't. What you need to know, this whole huge thing says 2 functions are inverses if and only if What notation do you recognize this at? It's a big, huge circle right now. Yours was really, really tiny, but it's an of, right? This is f of g of x and g of f of x both have to equal x. So we can verify if two functions are inverses by doing f of g and g of f, and they both have to be x. Somebody in here today is going to ask me, they're going to say, okay, I got x on this one, but not on this one. So are they inverses? What am I going to say?
No.
No, because they both have to be x, right? So let's do this one here first. And let's see. How about we split us up? The left half of the room, will you guys do f of g? My right half of the room, will you guys do g of f? And do you know what I'm asking you to do? Good. What's that?
There's two sets of functions.
We're going to do this one here first. And because my right-hand side of the room is smaller, I'm going to do yours with you. I'm on your side. You're my team. G of f. So I'm going to plug f into g. 1 minus. Did I do that right? Yes.
That's what I
All right. What did f of g people get? No one? No one? John, what'd you get?
Negative x plus 2.
You got negative x plus 2. Cambry, what'd you get?
I didn't hear problems anyway.
Okay, you joined our team. All right. All right. Addie, what'd you get? Okay. All right. So did either one of them equal x? So neither equal x. Neither equal x. And if this is my homework, can I get negative x right there and stop? I know they're not going to be inverses, and I can click they're not inverses. Yeah, if Alex doesn't make me solve for both of them anyway, which I think it does. So sorry about that. So they are not inverses. All right, let's come down to the bottom function. Let's trade it. This side of the room, you guys are now f of g. That side of the room, you guys are g of f. Because I did the problem with you, I'll do the problem with them.
The y is supposed to be an x.
Yeah, is it not? Make that an x. Thanks, Chance. Okay, I'm doing g of f. So f is going into g. How are my f of g group doing? What'd you guys get? X? Did you do f of g?
Also got X.
You also got x? Okay, f of g is also x. So are these two functions inverses of each other? Yes, they are inverses. So how do I verify if two functions are inverses algebraically? F of g and g of f both have to equal x. That's it. That's the lesson. Well done.